to align one sequence with the other sequence. Now we go to detail, logo and logo alignment. Logo alignment align and compare two sequence along that and time length. You see the on length. And come up with the back alignment. Display maximum number of nucleotide of amino acid alignment. And because two sequences not always equal length, so when compare the whole sequence, the program had to add gap. In hand program add gap, program use algorithm to add the gap. And this logo alignment applies when you run but the logo alignment works best when the sequence similar in character and length. Otherwise, program will add many gaps. And logo display the back align two sequence in line time. It may mix a small region of biological importance. What makes the logo alignment not suitable for large shots? You study large shots, lecture 4, and large shots use logo alignment, not logo alignment. You remember that, okay? For example, we have protein 1 and protein 2. And all protein have one important region. So the red one represents one important regions on proteins. So what is it? Domain. Okay? And when apply logo alignment, because two sequences are equal, so program will add the gap to make two sequences equal. For example, add the second gap, the second sequence only. Actually, the program will add either sequence 1 or sequence 2. Okay, and then actually we want to find out any domain between sequence 1 and sequence 2. But actually this one adds the gap and disrupt the sequence 2 and makes the important, the small region of biological important. What it is, we miss that. We miss the small region of biological importance. Likewise, the word alignment works best when the sequence is similar in character and length. In programs, we will apply the domain and words that the algorithm for alignment. 3 steps to global alignment: set up a matrix. You already studied how many matrices? 2. And then background on this computer with an escape in screen disappear on the computer. I cannot see anything. matrix. Actually, when you do the program already have the matrix set up as default. For the matrix, you already know how matrix score the alignment between two sequence at each position. And after that, identify the optimal alignment. So that means program will process many alignment and generate only one output, and the one output is the optimal alignment. A serial decision made at each step of the alignment to find a pair resident with the best score. So two parameters I already explained. The first one, the score, and the second one, E value. Remember that? Now we learn the first one, the blocks, the NCBI in the NCBI first. You go to the NCBI, get to sequence here, this sequence. Okay, you go to NCBI, get to sequence, and then we drop to see what happened. This is actually the alignment on class, and under class we have global align. You choose that. It is open nucleotide or protein in open toolbox. Open toolbox. You can copy sequence and paste the sequence directly to the box or you choose files. So you create faster files when you download sequence from the NCBIs, and you can choose file. What are sequence? 98 and 72. And you do the simplify in the other box. And you look at here, the parameter set defaults the existence and intention. And to remember, you have to open the file to see that protein or nucleotide sequence. So you have to change into nucleotide, not protein. And the parameters will be different. When you finish lecture today, I will explain about assignment 3. Okay? This is like intention. Only one. So I haven't explained about intention and existence. We learn the program first, and we will explain it later when we get the output. And then I will show you what the existence and what the intention. And look at here, because exam choice, question one will have one question ask you about the flow parameter. So that means before you run, you can to look at here, the parameter. Right. And you see the result similar to the last chart. The first part reports about the query sequence, the length, and also molecular time in query description. Because this one we use the sequence of NCBI ID, so that's why program also reports the ID the sequence. Okay, and you already know for the FASTA format, the first line the header short description, and after that follow the sequence that the FASTA file. And the header, in case you use your own sequence, actually here the ID, the content ID after you finish assembly, and this content will have one ID, and you use your own sequence report here. So this one actually the content ID, not the one from the NCBI. And you go down, you click here, show you the alignment, and I'll put almost the same with the last chart. Also show you a score here, okay? And score here, no with score, okay? Because this score only one alignment. You don't need to compare with the other alignment. So that's why no normalization. For the plot chart, because the plot chart have to compare one sequence with many sequence available in the database and have to compare alignment between. So that's why normalize in order to compare the alignment. But here the result only one alignment. So that's why no need normalization. So that's why you have the score, only one score. Actually this one raw score based on the matrix, to have the score, identity, and positive. And for identities, also the middle line, you look at if identity that letter, the same letter, mismatch empty and plus size, that means the similar property. Okay, that almost the same with the last chart. Now we move to the second program. The second program here in Mbox. In this link, you see many programs to categories, pairwise and multiple. Okay, pairwise and multiple. It depends on the program you choose. We apply different across global alignment or local alignment. So you click neither. And briefly explain about needle, global sequence alignment, and also 2 times protein of DNA and set up protein epitopes. And here also show you 2 boxes. The first box you copy sequence and paste directly to the box, or you choose 5 similar to the last. In the second files, you use the same file. And also, parameter here, assignment 1, assignment 3, the question 1 ask you the defaults. You look at the default here. Defaults about matrix, get open and get extend. Okay, you see, get open and get extend. And how we compare with the program in the NCPI, the class, the global alignment in class. So existent the same with the get open. And get open here set up 10. And get extend the same with this intention in the class. And set up 0.5. So you see, look at the value will depend on the program. We set up the value different, not the same. Existent the same, we get open. Intention the same, we get extend. But the value set up a little bit different, not the same. One thing the same. Existent and get open always high value. Intention or get extend always small value. And now we run to see the result. So now I'll show you the results. Get penalty and extend penalty. So what the get penalty? Get penalty, that means get open. Get extend, that means extend penalty. Even the same program, but generate the output you a little bit different top. Get penalty, the same we get open. Extend penalty, the same we get extend 0.5. And then the output also record the length here. 6 numbers, identity, the ratio. 560 over 691, 81%, that percent. Similarity, similar, also reward ratio and percent. The gap, any gap add between two, sequence or not, and score. Okay, you compare the score 2980, 2986, a little bit different because the scoring system not the same between two programs. And how to present the alignment. So this one's 1 bar represent for the identity. 2 dots represent for the similar amino acid. 1 dot, that means mismatch. Okay, and the gap here, you look at the gap. You don't confuse between 1 dot and 2 dots. And last week I already give you the file to interpret the results, Okay, understand 1 dot or 2 dot. And 1 dot here that means mismatch, difference, amino acid. Don't confuse with 2 dots. 2 dots that means similar amino acid. One amino acid can be substituted by the other amino acid, and that counts for similarity. Okay, after run the program, we look at before we go to get open and get this thing, we go to the local alignment first. Local alignment file optimally matching region within two sequences. So we'll find out where the optimal match between two sequences. Along with long sequence, we'll have many subsequences. Okay, because the program will find out where the optimal matching between two sequences. Roughly here, and then the optimal matching, and continue with the order region. The order region also have optimal matching. So many subsequent. For the program we use to run, the output a little bit different. The inputs when we run generate only the most optimal matching only, for example, reward for only one subsequent. That's the most optimal matching. But the other program will reward many subsequent. So depend on program you use. For the flash shots, Flash use local alignment, and local alignment Flash reward only the most optimal matching between two sequences only, not many subsequents. Local alignments only used for database searching, and we use large search. In large search, we will not use Smith and Waterman. In for alignment here, use Smith and Waterman. And this one also not apply for the flash shot I already explained, because if apply this one will process very long time. So that's why flash also not use this one. For alignment program use this one. For local alignment, find the region of the highest similarity between two sequence and build alignment. Our region. So find out the high similarity first and after compare both directions. If there are multiple regions of very high similarity, and I mentioned subsequence, many regions of very high similarity, the same principle apply. I mean, we will divide into many subsequent and compare each subsequent. Local alignment useful for sequence not similar in character and length. When two sequences unequal length, you should apply local alignment rather than global alignment. And why we do that? Because we want to find out small region of similarity, for example, the domain and dimension. We already run the embossed local alignment. Now we back to the local alignment. So this one, the result of local alignment, you keep it and then now you run local alignment. Okay, the same way. You look at the tool based on in sequence alignment and multiple sequence alignment. I haven't yet explained the difference. Factory, we explain it. We still keep in the pairwise alignment. We already run needle, now we run water. And look at the name. To calculate the local alignment. Local alignment. We use the same sequence. Submit it. You don't change any parameter. And the result here. So the results, identity, you compare here E equal 88.7 and 0.9. How about the water? The waters almost the same. Actually, the output must be different. Not the same. So the example, not a good example, because when we run local alignment will find out the high similarity between two sequence and the output will be changed. The identity and similarity normally in range. Because find out the high similarity between two sequence only, not the whole sequence. And I don't know this example, not very good example. Okay, at home you should run the example here. This two sequence here. Local alignment. And then local alignment to see the difference. Why not show the output? At home you run this example again, local alignment for two sequence and continue with local alignment with the same sequence to see any difference. And continue with gap and gap penalty. You look at the program will introduce either sequence to improve the alignment. That means to improve the score to make more neural time or amino acid between two sequence match. So that's why the program will add gap. Gap had to be introduced to improve the alignment. Because one of sequence may have gain or loss sequence characteristic in structure or relation during evolution that did not happen with the other sequence, what it means.